The origin of life is one of the most fundamental questions in all of science. How did we go from lifeless chemicals to living cells? And even more surprisingly, how did those cells eventually become us? Well, scientists have some ideas. They think it might have started with a very special kind of rock. There are rocks on Earth that are home to all kinds of microscopic life, like bacteria and fungi. These are called lithified microbial mats, or mats for short. The way they form is pretty simple. First, microbes like cyanobacteria grow in salty environments like shallow ponds or lagoons. As they photosynthesize and reproduce, their bodies build up over time, layer upon layer. Eventually they die, but their remains don't decompose because there's not enough oxygen around to support that process. Instead, they're incorporated into layers of sediment that get compressed over millions of years into rock. Now, while mats aren't super common today, we have found some examples in places like Australia and Spain. And we've also found the preserved fossils of mats that are billions of years old. These fossils tell us that mats have been around since at least 3-5 billion years ago. And researchers think that the earliest life on Earth might have originated in these very same environments. But what does that actually mean? Well, nobody knows for sure, but researchers do have a few good ideas. One theory is that the mats themselves were the first cells. Over billions of years, they evolved from simpler chemical structures and eventually became the precursors to modern-day bacteria. Another possibility is that the mats didn't necessarily give rise to life, but instead helped it along. Perhaps organic molecules that eventually became cells hitched a ride within the mat. Or maybe the mats provided a stable environment where cells could form and thrive. What's interesting is that we've even found evidence of microbial mats on Mars. So this may have been one of the first places where life arose too. In fact, given that both Earth and Mars had similar environments early on, researchers think that life may have independently evolved on multiple planets. That means the origin of life may not be a one-of-a-kind event, but rather a common occurrence in the universe. And the key to life elsewhere might just be rocks like these. But regardless of whether life began in mats or not, scientists agree that they played an important role in the development of early life. For example, many mats contain structures called stromatolites. These are layered mounds formed by photosynthetic microbes. As the microbes photosynthesize, they release oxygen as a waste product. Over time, this can lead to the formation of domes or columns of rock. We find stromatolites in the fossil record as far back as 365 billion years ago, making them some of the oldest known fossils on Earth. So we know that early life forms existed billions of years ago. But figuring out what exactly they were and how they lived is harder than it might seem. It's partly because a lot of early life was probably soft-bodied, like bacteria or single-celled organisms without cell walls. Those kinds of organisms rarely fossilize because they're so fragile. They tend to get lost to time, and all that's left behind are a few rare examples like bacteria that built shells or other protective structures around themselves. Luckily, we have a lot of those kinds of fossils to study thanks to another unusual rock type. It's called banded iron formation, or BIF. These formations are made of alternating layers of iron oxide and chert. Researchers think that the iron came from rocks on land that were eroded away and transported to shallow waters. Their microbes living in the water used enzymes to oxidize the iron, meaning they reacted it with oxygen. This caused the iron to precipitate out of the water and form the distinctive bands we see in BIFs today. We don't know for sure which specific types of microbes were responsible for this process, but it had to be the kind that could survive in highly acidic conditions. And we know that these bacteria were thriving around 2-5 billion years ago when Earth's oxygen levels were really low. By studying the chemistry of BIFs, scientists have even figured out that the bacteria must have been using anaerobic respiration, meaning they were able to get the energy they needed without using oxygen. In other words, these rocks are helping scientists piece together the history of early life on Earth, one layer at a time. And to learn more about how life got started, you can check out the series in the description below.